Hello again, Econ 160. It's Professor Kung here, coming to you with another video lecture. It's currently March 30th, 2020 as I record this, and it's day 13 of California's official coronavirus lockdown, and probably about a week or so later for those of you watching right now. As of today, there are 145,000 confirmed cases of coronavirus in the US, and medical professionals aren't expecting us to peak for another week or two. So I hope that wherever you're watching from, that you're staying safe and staying healthy, and that your families are safe and healthy as well. Today's lecture is on the topic of monopolies. In our previous lecture, we looked at perfectly competitive markets. That is, markets with a lot of buyers and a lot of sellers, and where firms could freely enter or exit the market. But the sharp observers among you may have quickly realized that this isn't really a very good description of all markets, right? Instead, there are some markets that seem to be dominated by just a single supplier, such as your local power company or maybe your local internet service provider. So why is this the case? Why are some markets dominated by a single supplier, while other markets have lots of them? What characteristics of a good or of an industry make it more or less susceptible to being dominated by a single supplier? And finally, how does a market with just one seller behave differently from a market with many sellers? Those are some of the questions that we're going to address today. The picture on the right here is of John Sherman, a U.S. Senator from Ohio, who wrote the Sherman Antitrust Act of 1890. The Sherman Antitrust Act is the law by which the U.S. government derives its power to regulate and break up monopolies, which is the subject of our lecture today. So what is a monopoly? The dictionary definition of a monopoly is that it's the exclusive possession or control of the supply of or trade in a commodity or service. So the word monopoly is a noun, and it's something that you either have or you don't have. So we can say something like, Google has a monopoly on the market for internet search, or LADWP has a monopoly on the market for electricity in Los Angeles. A firm that has a monopoly in a market is called a monopolist. But you'll often hear the term monopoly get used quite loosely in reference to either the firm itself or to the market. So you might hear someone say that Google is a monopoly or the market for internet search is a monopoly. But in both cases, we can reasonably infer what they mean. Okay, and finally, Monopoly is a bad board game. All right, sorry if you like it, but really you should be playing better games. And if you need recommendations, I might have some for you. So, where do monopolies come from? Why are some markets prone to monopolization, but not others? Well, monopolies arise when there are strong barriers to entry. A barrier to entry is something that makes it difficult, or even impossible, for other firms to enter the market and compete successfully with the dominant firm. The types of barriers to entry include extreme economies of scale, network effects, monopolized resources, or government-created barriers. And we're going to discuss each of these in turn. So first, extreme economies of scale. As a reminder, economies of scale means that the firm's average total cost is going down as the firm gets larger. And really, this is just a fancy way of saying that the firm has very high fixed costs, but low marginal costs of production. So for example, a local power company has very high fixed cost because it costs a lot of money to lay down the infrastructure necessary to deliver electricity from house to house. But it has low marginal cost because once the power grid is completed, the cost of hooking up one additional house to the grid is pretty small. Another example would be your local cable company. Again, for the same reason. It costs a lot to lay down the cable network necessary to deliver internet and cable TV to homes, but once that network is laid down, the cost of adding one person to the network is pretty minimal. So the thing about an industry with extreme economies of scale is that naturally, the largest firm is going to become the lowest cost producer. This makes it hard for smaller firms to start up and enter the market and compete successfully. And so over time, the market would gravitate towards a single supplier because the largest player is going to become the most efficient and the most competitive, and thus able to drive the other smaller firms out of the market. Our second barrier to entry is called network effects. An industry has strong network effects if the value of a firm's product increases as the number of users increases. So a lot of modern internet companies have this feature, especially social media companies like Facebook, Twitter, Instagram, or YouTube. And that's because people primarily use these platforms to connect with other people or with the content created by other people. So the more people there are on the platform, or the more content creators, then the more valuable the platform becomes to its users. Another example would be certain kinds of productivity software, with Microsoft Office being a prime example. If you'll notice, pretty much every document processor and spreadsheet software these days conforms to the standards of Microsoft Word and Microsoft Excel. And that's because these tools have become so popular and so well known that pretty much everyone uses them or some version of them. And on the plus side, that means that there are a lot of resources out there for learning how to use these things. And it also means that we can transmit files to each other easily and collaborate easily. But a downside is that there isn't much room for a paradigm change in terms of how we do our document and spreadsheet processing because of the dominance of the Microsoft Office framework. So in an industry with strong network effects, the company with the most users also tends to have the most valuable product. And that makes it hard for existing users to switch to a new product, even if they like the new product's features better, because they rely on the user base of the old product. So you can imagine, for example, some popular YouTuber thinking about switching platforms off of YouTube. But where would she go where she could get the same amount of viewership that she gets on YouTube? Probably nowhere. And so this makes it hard for small startups to enter the market and compete successfully, simply because their product just won't be as attractive as the large firms due to a lack of users. And so in many cases, these kinds of startups might just get acquired by the larger firm, and then their features get added to the larger firm's dominant product. So in a way, network effects are like economies of scale because firms get more competitive as they get larger. In fact, we have a word for markets where the largest firm is naturally the most competitive, and that's what we call a natural monopoly. So we call markets with extreme economies of scale or very strong network effects as natural monopolies because these markets would naturally gravitate towards being dominated by a single supplier, even without any sort of outside interference. So an interesting feature of natural monopolies is that it might actually be the most socially efficient thing to do to let the market be served by a single large firm. So just for example, does it really make sense to have two power companies own and operate their own independent power grids? And similarly, does it make sense to fracture the online video community into two platforms? Or does it make sense to have them all searchable on one dominant platform like YouTube? But the downside to this is that the dominant firm is then going to have a lot of market power, which it can potentially abuse in a way that is harmful to consumers or that potentially stifles innovation. So regulators have to balance the potential efficiency gains from letting the market be dominated by one firm with the potential abuse for market power. Our third barrier to entry is what's called monopolized resources. This isn't a natural barrier in the sense that it arises from the nature of the product or of the industry itself, but instead, this is more of an artificial barrier which is created by people. But to put it simply, one way to have a monopoly on something is simply to own or control all of the resources necessary to make it. So for example, if you own all of the diamonds in the world, then no one else but you is going to be able to make diamond rings. Now, this actually kind of happened in real life. At its peak in the early 1900s, The De Beers Diamond Company was estimated to have controlled almost 90% of the world's diamond supply. And it also happened in the real-life town of Bikini Bottom, where a restaurant known as the Krusty Krab was able to monopolize the town's fast food industry by being the sole owner of the Krabby Patty secret formula.
Where's me formula, Plankton?
Okay, lastly, we have what's called government-created barriers to entry, or legal barriers to entry. And these are when the government actually grants monopoly rights to a company, usually through the patent or the copyright system, collectively known as intellectual property. So what's the difference between a patent and a copyright? Well, they both grant the holder the exclusive right to use something, but for patents, it's for inventions like a new drug or a new drug delivery method. And for copyrights, it's for works of art, like a character design or a song or a novel or things like that. Now, the purpose of patents and copyrights is to encourage the creation of new ideas and new works of art, which, if you'll remember, have public goods-like characteristics, non-rivalry and non-excludability, and so they would therefore be underprovided by the private market if they weren't somehow being incentivized by the public sector. Now let's talk about the similarities and differences between firm behavior in a monopoly and in perfect competition. First, for similarity, we're going to assume that just like for a perfectly competitive firm, a monopolist's goal is also to maximize economic profits. Given our very broad definition of economic profit, this isn't a bad assumption. The main difference now is that the monopolist is not a price taker. Since the monopolist is the only supplier in the market, it can actually choose whatever price it wants. And since there are barriers to entry, no competitor is going to come in and try to undercut the monopolist if it sets too high of a price. Now, one thing to keep in mind is that saying that the monopolist can choose whatever price it wants is not the same as saying it can choose whatever price and sell however much it wants. So for example, Apple can charge whatever it wants to charge for the iPad, but it can't charge $1,000 for the iPad and still expect to sell millions of iPads. So even for a monopolist, there's a trade-off between price and quantity. And that trade-off is going to be given by the demand curve. So we say that the monopolist is bound by the demand curve. It can choose any price and quantity combination which is on the demand curve, but it can't go off the demand curve. All right, so let's work on this example of monopoly profit maximization. Here on the left, I am showing you the demand curve that is being faced by a monopolist in the market, and here in the middle is the monopolist cost function. On the right here is a table that we're going to fill in to find out how the monopolist can maximize its profits. We're going to think of the monopolist as choosing how much quantity it wants to produce, and based on its choice of quantity, it'll determine the price that it would need to set in order to sell that quantity. So this is equivalent to choosing the price directly, since for a monopolist, the relationship between price and quantity is 1-for-1, and is given by the demand curve over here. Okay, so let's fill out the table on the right. We're going to start with the price column over here. So to fill out this column, what we need to ask ourselves is, for the quantity that we're choosing to produce, what is the price that the monopolist would need to set in order to sell that quantity? So for 0, what would the price have to be if the monopolist wanted to sell 0? Well, it says right here on the demand curve, the price would have to be 11. Okay, so what if the monopolist wanted to produce and sell 1 unit? Well, it says here on the demand curve that the price would have to be 10. So what would the price have to be to sell 2 units? It would have to be 9. For 3 units, the price would have to be 8. 7 for 4 units, and so on. 6, 5, 4, 3, 2, 1, 0. Okay, so we're really just reading off the demand curve here. All right, so now let's do total revenue. If you remember, total revenue just means the amount of money which is coming in for the firm. And in this case, it's just equal to price times quantity, right? It's however much you sell times the price that you sell it at. So if quantity is 0 and price is 11, then total revenue would be 0. If Q is 1 and P is 10, then total revenue is 10. If Q is 2 and P is 9, then total revenue is 18. Okay, and then we have 24, 28, 30, 30 again, 28, 24, 18, 10, and 0, right? So that's total revenue for each quantity chosen, okay? And now let's do total cost. Total cost is going to be easy because we're really just going to be reading straight off the cost function. So if the firm wants to produce a quantity of 0, then total cost right here says that it'll be 4, right? So that's your fixed cost. The firm is going to have to pay that 4 regardless of how much it chooses to produce. All right, if the firm wants to produce 1, then the total cost will be 5. Total cost if the quantity is 2 is 7. Cost is 10 if it's 3 quantity, 14 for 4, 19 for 5, and so on. We are reading straight off the cost function right now. Okay, so that's our total cost. All right, so now let's fill out marginal revenue. So what's the additional revenue which is gained by the first unit? So we're going from a revenue of 0 to a revenue of 10, right? So the marginal revenue is 10. What's the marginal revenue of the second unit? Well, we're going from 10 to 18, so the marginal revenue is 8. And for the third unit, we're going from 18 to 24, so the marginal revenue is 6. All right, and so it's 4 for the fourth unit, 2 for the fifth unit, 0 for the sixth unit. All right, so how about for the seventh unit? For the seventh unit produced, revenue is actually going from 30 to 28, right? So the seventh unit actually loses us 2 revenue, so marginal revenue is -2. So how can producing more actually lead to a loss in revenue? Well, the thing about the monopolist, right, is that it's not a price taker. So in order for this monopolist to sell 7 units, it actually has to reduce the price, right? And so in this case, the effect of reducing the price totally offsets the increase in quantity sold in a way that actually loses you revenue, okay? All right, so what's marginal revenue for the 8th unit? Well, we're going from 28 to 24, and so the marginal revenue is -4. -6 for the 9th unit, -8 for the 10th unit, and finally -10 for the 11th unit. Okay, now let's do marginal cost. The marginal cost for the first unit is 1 because we're going from a total cost of 4 to a total cost of 5. It's 2 for the second unit, 3 for the third unit, 4 for the fourth unit, and so on, right? 6, 7, 8, 9, 10, 11. Okay, so there's our marginal cost. All right, so at this point, if I were to ask you what quantity maximizes profit, you could simply look at the table here and realize that profit is going to be maximized when marginal revenue equals marginal cost, right? That's true for all firms. And that happens at a quantity of 4, okay? And just to be sure, let's actually calculate what the profit would be at each level of quantity. All right, so at a quantity of 0, revenue is 0 and cost is 4, so profit is -4, right? The firm is losing 4 by producing 0. At a quantity of 1, the total revenue is 10 and total cost is 5, so profit is 5. Okay. At a quantity of 2, revenue is 18 and total cost is 7, so our profit is 18 minus 7, which is 11, right? And then 24 minus 10 at a quantity of 3, it's 14. 28 minus 14 is again 14. 30 minus 19 is 11. 30 minus 25 is 5. 28 minus 32 is minus 4. 24 minus 40 is minus 16. 18 minus 49 is 49 minus 18, so negative 31. 59. 10 minus 59 is negative 49. And 0 minus 70 is negative 70. Okay, whew, that was a lot of mental math. All right, but if you look here, you would see that indeed the highest profit that you could achieve is 14, and you do indeed maximize your profits when marginal revenue equals marginal cost at a quantity of 4 and a price of 7. Okay, so that's it for the first half of the lecture, and I hope you'll join me for the second half.